All right, 9.4. This time we are going to maximize the volume of a square-based prism, okay? So yesterday we were minimizing the surface area, and we figured out that to get the best volume with minimizing the surface area, the square-based prism was going to be a cube. It was going to have three dimensions the same. Minimizing means using as little as possible.
Oh yeah.
Maximizing means getting as much as possible. Okay? So we minimized surface area yesterday. We used as little cardboard as possible for a box, basically. Okay? Now we're trying to maximize the volume of a square-based prism. So let's look at this. Each of the square-based prisms in your investigation has a surface area of 24 centimeters squared. So they're all using, if they were boxes, packaging, whatever, cereal, let's say, they would be using the exact same amount of cardboard to package the cereal. Our goal is to figure out which box can fit the most cereal. Which one maximizes the volume. Okay? So calculate the area of the base and the volume of each prism. Record your data in the table.
That's a big question. In our test, we had a question.
So go ahead on your investigation. We have prism number 1. It has the square-based, it's a square-based prism. So the side length of the base of prism 1 is 1. Okay? Which means the area of the base is 1 times 1, which is just 1. Okay. Let's go to prism 2. The side length of the base is 2. So the area of the base is 4 centimeters squared. Prism 3, side length of the base, 3 centimeters. So the area of the base, 9 centimeters squared. Now they each have the same surface area. They've made sure of that for us. We don't need to worry about it too much. What is the height of the first prism? 5.5 centimeters. The height of the second prism? 2 centimeters. The height of the third prism, 0.5. Good. Now we can calculate the volume. How do you calculate the volume of a prism? Length times width times height. Go ahead. So here we've got length and width are both this dimension because it's a square base. So you have 1 times 1, or really we just do the area of the base times the height, right? That's how we've learned it before. So let's do that. The area of the base times the height. This tall, skinny prism has a volume of 5.5 centimeters cubed. What's the volume of the second prism?
6 times
4 times 2, 8. And the volume of the third prism? 9 times 0.5. So we're just cutting it in half, right? 4.5. Good. Which square-based prism has the maximum volume?
5.5. Number 1.
8. Number 2.
Oh, dang.
The cube always wins. I don't even know why we do
Number 2. Describe its shape.
The cube always wins.
Describe its shape.
What was the cube's name?
It's a cube.
It's a cube.
It's a cube.
Good
His name
answer.
is Cubert. No. Cube. Get it.
Okay.
Kevin the Cube.
Okay, guys. So what we've learned yesterday, if you want to minimize surface area while having the best volume, you're going to pick a cube. Today we're learning if you have a set amount of surface area and you want to have the best volume inside that box, you're going to pick a cube.
What if you
So,
were
here we go.
Minimum and the maximum?
Minimum surface area, maximum volume. Cube is the most efficient packaging shape. Unless you're dealing with other factors like carrying it or what goes inside. Okay?
It still boggles my mind that they all have the same surface area, but other ones have more volume. How does that make sense?
Same. It just.
Yeah, so picture this. Picture like a really long, skinny thing. Well, it's the same thing we learned about in 2 dimensions. Like I can use this much fence to get a long, skinny, almost no space at all. Picture this. You could make it even longer and skinnier.
How do you make this skinny?
And you could get so long and skinny that it ends up just being a line with virtually no area in
I
it
know,
whatsoever.
but if you
So now if I take this line and I bend it here and I bend it here and I bend it here, I get a shape like this, which has lots of area. Same line. No area, lots of area.
I know, but what if you like squished it all together? It would go into a cube. Like you could like compact it.
Yeah, that's basically what you're doing, is you're stretching this dimension, shortening this dimension. Right? Using the exact same perimeter when you're talking about rectangles. And we said the same principle applies when you're talking about three-dimensional objects, and you relate surface area to volume. Okay, let's dig into the example here. We're going to maximize the volume of a square-based prism. So in A, we're going to determine the dimensions of a square-based prism with maximum volume that can be formed using 5,400 centimeters squared of cardboard. Okay. A. What kind of prism are we going to be building?
Square cube.
A cube, okay? So
Kevin.
the square-based prism with the maximum volume, comma, given the surface area, comma, is a cube. Okay, let me walk through that with you 1 second. Basically what I said is, given the surface area. So if you know the surface area, then the maximum volume, then the shape with the maximum volume is going to be a cube. Okay? If you know the surface area and you need to maximize volume, you're going to use a cube. So here we go. This means that the sum of each of the 6 square faces of the cube is going to be 5,400 centimeters squared, because that's the maximum amount of cardboard we're allowed to use. Okay, that's the maximum amount of skin going around. That's the max surface area. So what we're going to do is we're going to let S represent the length of each side of the cube, and we're going to calculate the surface area of a cube. Well, what's the surface area of a cube? Think about it. Does S cubed give us the surface area of a cube?
Yeah, no,
It gives us the
yeah.
volume of a cube.
Centimeters squared.
Yeah.
Ah, length times width times 6. Everyone, we're going to draw a net for this cube, okay? We're going to draw a net for this cube. So this is one face, and if we could break that cube open and lay all of its faces, we'd have 4 faces going this way, all identical, and it doesn't matter where you put the 2 other faces as long as they are connected on either side, kind of like that.
What if you put one on the very top and split it like a square?
If you put it here,
Yeah.
you would not make a
No,
cube
on the
anymore.
other side,
Over here?
No.
Over here, over here,
No.
over
right
here.
there. Yeah,
Yep.
over.
Any. I could put it anywhere on this
Right
side.
there.
Yeah, anywhere on this side. Okay, and we know that this side is S, this side is S. So all we want to do is we want to get the area of one face and multiply it by 1, 2, 3, 4, 5, 6. 6 faces. So we've got 6 times S squared. We know what the surface area is in this situation. What surface area are we allowed to use?
4,500.
5,400 equals 6 times S squared. Okay, a little bit of algebra here. We want to figure out what S is. What is the first thing I can strip away from S?
Squared is
6.
Whenever we're solving for a variable, we use bedmass backwards. So there's nothing to subtract or add.
We use whenever we're solving for what?
Whenever we're solving for a variable,
Oh, yeah. Using bedmass.
we're going to use bedmass backwards. So there is multiplication. How do I undo multiplication? So what am I going to divide this side by?
6.
Am I done?
No.
Nope.
I have to
Do the other side.
divide this side by 6. Okay, I'm going to flip the sides here so that I have my s squared over here. And 5,400 divided by 6 is 900. Now I want to get
Square
just
root of.
s, so I take the square root of both sides.
Anybody.
Square root of 900 you can do in your head.
30.
No.
36.
Let me
30.
quick.
30.
And we're dealing with centimeters here. So the square-faced prism with maximum volume is a cube with side lengths of 30 centimeters.
How do we get the maximum volume again?
We just know that the square-based prism with the maximum volume is going to be a cube. We haven't gotten the volume yet.
And to find the minimum volume, you just cube root it.
Right now we were given a surface area and we had to decide what were the dimensions of the cube. That's it so far. Okay? In B says, what is the volume of the prism? Well, now that we have the side length of this cube, we can determine the volume. How do I do that? What's the volume of a cube? S cubed. And I already know that S is 30. So I have 30 cubed. What's the volume?
27,000.
Okay? 27,000 what?
Centimeters.
Centimeters cubed. The volume of the cube is 27,000 centimeters cubed. Your practice problems are on the next page. You are free to begin those.